Jó napot, kedves HUSTEF 2016! Again, this is a non-functional section, so everybody stand up as before and go away. Good afternoon, dear HUSTEF 2016. I'm really honored to give this talk and pull you into the topic, testing in automotive. We test it, you drive it. Yes. Who am I? I am system test engineer, certified ISTQB tester, working for the biggest engineering company in the Czech Republic, in the department of electronic validation. I have one unusual hobby, quite untypical, and it's called software testing. Is here anyone else interested in this topic? Raise your hand. Oh, good, I'm not here the only one. My daily bread is to help people live life behind the wheel less risky and guarantee that every interaction of electronics in the car runs smoothly every time you do it. Now you are familiar with who I am, but why should you listen to me? As I told you, I would like to pull you into the topic of testing in automotive and answer a few questions you might ask yourself. Questions beginning with what, why, how, where, when, and who. What? What does ECU, the term on which testing in automotive is based, exactly mean? Why? Why do we test at all? Why is testing in automotive so important? How? How do we test? Where do we test? And how does this whole development and testing life cycle work? When? When should we start with testing and when should we end with testing? And who? Who does this job? And how does the day of the tester look like? ECU, abbreviation for electronic control unit. The name given to device or embedded system that controls other system or subsystems. The ECU provides instructions to other systems how they should work, how they should communicate with each other, and what to do. There is a number of different ECUs and as well almost endless amount of different types how we can divide them. One of the possible way is powertrain drive, for example engine control unit. The next one is communication systems, there is information system. Comfort body, seat control unit, and safety system. For example, anti-lock braking system. These electronic control units communicate with each other. And that's happening thanks to controller area network called CAN bus. It's basically said message-based protocol which is designed for multiplex automotive wiring without automotive. Consider typical mid-size car. In early 90s, it had 4 electronic control units and about 300 meters of cables in total. 20 years later, a comparable one with 61 electronic control units and almost 4 kilometers of cables was introduced. As Plato said, we have to spend money to make money. So in between 3,000 and 4,000 euro are the costs in warranty period for premium cars. A part of this amount of electronics is 50%. So imagine, by production of 100,000 cars per year, the costs are 400 million euro. That's a big number. That's why it's essential to test every single electronic control unit already in initial session, because the later we do it, the more expensive it will be. And the top of it, if you find an error in already made car, it's usually too late, and the costs are skyrocket. The earlier, the better. Nowadays, every single car is tested. No exclusion, no exception. Safety first. Functional safety is condition of compliance for doing business in automotive. Complexity and number of electronic control units has been extremely growing in the last years. That's why the new standard was implemented for functional safety. These standards tell me or help me to set up processes which I have to follow to provide whole functional safety in the car. It means, for example, development steps, requirements for construction, requirements for testing, and after that I can provide full functional safety. Here on this simple chart you can see that we have to apply hazard controls until remaining risk is acceptable. After that we can claim that the system is safe. Safety first again. Imagine two situations. The first one, you have an airbag which inflates itself when it's not supposed to. Second situation, you have an airbag which doesn't inflate when it should. Which situation is more safety related? I would like to after that see your hands. So, which situation is more safety related? First situation, I have an airbag which inflates itself when it's not supposed to. Who thinks this is safety related option? Okay, I see 35 raised hands. 36, sorry. Second situation. I have an airbag which doesn't inflate when it's supposed to. Who thinks this is safety-related hands? Okay, I see 37 hands. Interesting is that the first case is safety-related, because after that I am not able to continue in driving. The point of functional safety is that when it works, it has to be 100%. You always have to ask yourself, am I able after that continue in driving? So that's why the first case. Another situation. Happy driver Petra wants to turn left. The indicator function works, and as well outside blinker works. Everything is fine. After that, I would like to turn left, but my indication function on the dashboard doesn't work, but cars outside can see that I would like to turn left. It's not completely okay, but I know about the problem and I can continue driving. So, not functional safety related. The last case, here is actually a mistake on the slide. Imagine that happy driver Petra wants to turn left, and the indication function works. So I think, yes, everything is fine. But the cars outside don't know that I would like to turn left. So it's safety-related problem. We have no functional safety in this case. It cannot happen that when I think something is happening, it's actually not happening. That is functional safety. Development and test life cycle. At the beginning, there was traditional waterfall model, which is referred to linear sequential life cycle model. There are two teams, developers and testers. Firstly, functionality is developed, and after that, system is tested. These two phases don't overlap. Here I would like to focus on the down part of the testing. So after that, architecture and model is designed. After that, we start with testing. Firstly is ECU component testing. It means that we test every single electronic control unit, isolated from the rest of the code. After that follows ECU integration testing. It verifies that these isolated components can cooperate with each other and coexist with each other. The last part is in-car testing. So we simply these real electronic control units put into real car and data are observed. Maybe you ask yourself how from this circle I am able to do this famous V model easily, just by one click. Or 3 clicks? Yeah, good. Yes, good. On the right side, there is development process. On the left side, there is testing process. This V represents as well relationship in every horizontal phase. What does it mean? It means that we start with testing already when development starts. During the development of test plans, we can already discuss criteria, inputs, outputs, and so on. Yes. And one more click. When we talk about testing phase, we have 3 validation stages. 3 validation stages for validating of these electronic control units, if they work or not. The first one is model in the loop and software in the loop. They both, model and software, are running on the virtual environment. The main difference is that the firstly model is tested and after that generated code. Model. For model, inputs are simulated, and after that output values are saved, and we are discussing if it's what we expected or not. By software, everything is simulated as well, and everything run on PC or some evaluation dashboard. We use for that MATLAB or Simulink. Hardware in the loop. Upgrade. Now we test real electronic control units. So it means that the environment is simulated, and we simulate it with environment modules. But inputs and outputs are connected to Hill simulator. And the last is in-car testing. This part people from my team love the most, guys driving the cars. In this phase, the real electronic control units are implemented into car, data are observed and converted, and so on. When mission can be possible for Tom Cruise, why it shouldn't be possible for us? Let's try to test it. I think everyone here owns one mobile phone. Let's take it out. Great. Now look on it and think that you have 5 minutes. Which test should be done to fulfill the functionality of this mobile phone? One more question. How much time do you think would be needed to make the complete test of this mobile phone? Do you have any suggestions? How many minutes, how many hours, how many years? before you start to answer, there is no correct answer. Don't worry. Because the strategy of this mission, strategy of testing has to be proper, has to be thought out. We have to consider money, time, people in this team, and so on. So there is no proper answer. It might be that as we now were lost for a while in this topic, the testers could be lost in this topic. But don't worry, puzzled, confused tester. If you have requirements and after that list of the issues and you don't have any idea what to do with that, if you follow 5 key steps of V model, you will hit the target. It's a test strategy, test planning, test specification, realization, and evaluation. Let's be welcome in our team of testers. We are a group of different teams. Everyone has its expertisement and everyone has its tasks. The first team is test strategy. Strategists firstly read documentation and collect all information how the process, how the system should work. So they loudly discuss. The second team is test planning, not the quietest team neither. Because it's not that easy to divide roles, to say what will do what, and to define some milestones. After that, we are moving to the second floor of our company, where our test specification team. These test specification, test designers have to again read all requirements, and after that they have to find a method to test every functionality of the system. The last team is test realization and evaluation. My team, the best one, no doubt. We are partly working by some computers and partly working in laboratories by big hill benches where we evaluate our data and we execute tests and re-execute tests who previously failed to confirm that the error is fixed. So evaluation and realization. How many of you here owns the car? Who has a car? Good. How many of you drive the car when the lights are switched on? The exterior lights are switched on. It should be exactly the same amount of the hands. Come on, you don't drive the car without lights switched on. Rebels. I would like to give you the real example of my experience when I was testing electronic control units for one of the biggest manufacturers in Europe. I was testing exterior car lighting, and I was the master of it. Every system is described by features and functions, where the feature is a package of functions. Every function is after that described by these tests, where we check the left blinker, live blinker, if it's blinking, on call for blinking, and so on. These tests run during the night, so it's called night tests, and at the morning we come to our computers and we see if it's green or red. If it's green, test passed. If it's red, test failed, and we have to fix it. And now we are at the end. I was looking for some tips how to kick my presentation, how to make the killer impression in the last minute. And there was written that I should ask myself 3 questions. The first one, who am I? The second one, who is my audience? And the last one, what I want from my audience. So, who am I? I am system test engineer who helps people to drive car less risky. Who you are? You are great software engineers who are excellent in their jobs in different fields and people who are interested in this topic. What I want from you? To memorize everything what I just said, to know every 3 validation stages I just mentioned, no thanks. I want only one thing. Next time when you sit in your car, feel special. Realize it's not only a bunch of some velvet plates together. Behind all of this are 10, hundreds, thousands of hours of discussing, developing, coding, and testing. Behind all of this are nights and days of testers sitting in cold laboratories and thinking about processes you don't have to take care about. Processes like opening the door, fastening your seatbelt, switching on the engine, or switching on radio. Processes you do automatically, we think about it. To enable you to not think about it, to rely on it. Because we test it, and you drive it. Köszönöm.
Why in MIF meal phase the model output is not defined before running the experiment? Doesn't this contradiction design of experiments theory?
Then I understand the question, good question, because actually the output is defined, but it's not real. It means that it's defined, but it's simulated as well after that it's saved, and it's just compared to what we expected. This is a good question because we don't know exactly. Cars, automotive manufacturer just keep it as a secret. This 61 was 20 years ago. Now my amateur guess is about 100. But it always depends on which society is this car, if it's some lower one or higher one. And as well, for example, from my experience, one car had like 150 ECUs, but bus has less, has 60. So I was testing buses, so we had less ECUs than some good cars. The question was, how many electronic control units are nowadays in cars? And my answer was, hard to say, but it will be a big number.